That is really exciting. I love it when everyone makes it to class. Okay, we are all here. There is a warm-up today at the top of the sheet. I'm sorry it was unpublished for some reason at the start of the day. Let me go to the fabulous presentation. We're going to present, and I've been told that presenting doesn't work. So I'm going to stop, reshare. I can't tell you the question that had the wrong answer. Oh shoot, silly me, I've got to do this. So here, let me go through this and then I will get to that. The test had multiple ways to try and avoid cheating. One of those is that the questions are randomized. They come out in different orders and things. So technically it was question 4, but I don't know how it may have changed on your sheet. Today we got the warm up in Canvas. We're gonna do lesson 3. We're gonna go back into the crazy widget for lesson 3 and get that done. And then you can do your U2L3 sheet. The easiest way, let me just do this on screen so that everyone sees. Go to my crazy desktop, which is always exciting to demonstrate. So U2L3, need for addressing. When you click on that, it has your U2L3 sheet right here. Use the activity guide here. Ideally, there's no sharing issues. Let me know if you have sharing issues. You're going to need to make a copy of it and then use that for your sheet. Okay? So that's it. Let's see. All right, we're going back into present mode. We're stopping sharing. We're starting sharing. We're going into our lecture that is 1 slide ahead, 3 slides ahead. So what we're going to do is we're going to go in 4-person breakout rooms because in theory 4 people is going to make it a lot quicker and easier for you. You've only got to make 3 dates in there. There is always going to be an extra day. I found that out last night. Some people were very concerned that like they were having to make an appointment for themselves. If it's a 4-person group, we're going to take off Saturday and Sunday and you're going to create a day for yourself. That leaves 4 days for making appointments. So when you make your appointments, 1 day is going to end up free, or as people thought yesterday, basically you're making an appointment with yourself for that day. You need that extra day to give you the wiggle room to make this scheduling thing work. Sorry about that. Heating and air conditioning man has arrived. So if we can get through with that, we're going to go into routers and redundancy, unit 4, and basically the same thing. We're just going to try and get into the widget and get an understanding. What's going to happen, what is happening in 3 is that it is broadcasting in your network. You're sending your messages to everyone, and you're going to figure out how to make your scheduling through that. In 4, they're adding a router to the system. So you have to address your comments specifically to an individual in the system. You'll see, we'll figure it out. So what is due today is your U2L3 need for addressing activity guide. Some people in theory were able to get it done before. I'm not sure how, since you didn't have people to work with. I know people were working on this, and I'm very sorry it was so confusing, and the link to the activity guide didn't seem to be working, which it wasn't. But the activity guide was in the lesson, is the crazy part. So I know this has been confusing. We're trying to keep this at a pace where we can all really understand the work that we're doing, but it's that issue that because we're in AP, everyone's moving as quick as they can, as quick as we possibly can while having good learning. So let me know in the chat or however, if you're feeling left behind or there's something I could be doing better to help you through this process. Our goal is you will be able to explain how computing devices can be connected to form a network, explain the need for open and shared protocols for communicating on the internet, and describe the way the internet protocol helps uniquely identify one another on the web. Okay, let me get back to the fun thing. So the test. This was the question. Hang on. I'll share my crazy desktop with you for fun. So this was the bad boy. Apparently, which of the following best describes how computing devices represent information? What was checked off was a computer will either represent information as bits or bytes, but not both. That is not the right answer. The right answer is a computer represents data as bits, which is either 0 or a 1. That's the answer. So again, we gave everybody a point, which is always nice. I looked through everyone's grades. And anyone who got a 10 did not have a point deducted for doing this. There were a couple people who were not able to take the test, and that really makes me unhappy. So I'm not sure what we're gonna do about that. We had our makeup day yesterday. If you wanted it, you could have come. But I will do what I can to help you out. So let's get into today. Stop sharing, start sharing. Okay, in the breakout rooms, you should get everyone's code.org screen name down on the activity guide so that when you go on the simulator, you can find each other in the waiting room. So you got to do that before you go in there. Big warning to everyone. Once you go in a room, do not close your tab or you will not be able to get back to that spot that you had in the room. Don't close tabs on this. If you close a tab, you'll be in there and you're gonna have to join again. I have not gotten information from code.org as to how to clear out a room. My thought is the only way to do it is just to start a new room and then populate that. So that has been an issue for a lot of people, that they have gotten locked out of their rooms because they have closed tabs. Be very careful of that. I've done it to myself. You can do this by yourself if you open up like 4 tabs on your browser. So if needed, use a split screen so you can see both the Internet Simulator and the activity guide. The Chrome store has a lot of split screen apps for free. The other way to do it is just open up a tab independently and size that so that it's right beside you. As you use the simulator, record any problems you face and brainstorm solutions. Use the activity guide to build a network and create rules for sending messages to discrete individuals in a standardized way. So, everyone is going to have to arrange a visit. Oh, we lost Kenneth. Welcome back, Ken. So the idea is you need to make a date with 3 of the other people in your group on 3 different days. 1 person, 1 day. 1 day will be open. When you go in to do week 2 in the simulator, you will not be able to talk to each other. You will be able to talk to each other for the first one. Think about what questions you need to ask to set up these play dates when you can't talk together. So you need to say specifically, okay, Jim, can I make a date with you on Tuesday? Betty, can I make a date with you on Wednesday? Tom, can I make a date with you on Thursday? You need to figure out what is the systematic way to be asking these questions so that everyone is going to get covered, everyone has a date, and all your calendars match. You need to compare calendars at the end to make sure that they match. When we go into the simulator, you are not creating the same dates, you're going to be creating new dates. You just need to shift everybody. But the difficult part is that you can't talk to each other. We're going to try and do it twice in the simulator. All right, let's see if we can get to this. So with your group, follow the directions given in the box for week 1. We're not going to try and do groups of 5. Somebody might end up with one. You get rid of Sunday in a group of 4. You get rid of Sunday and Saturday. Before starting a schedule each week, choose a random day of that week when you're busy and cross it out. Once your group is ready to fill in your schedules, with your group, check that everyone's schedules match, then discuss what worked well and what is tricky. If there's anything you want to try differently in week 2. Okay? So let's do breakout rooms. Why isn't my breakout room working? For some reason, my breakout, oh, there we go. Okay, so it's going to have to be 4 to 5. I'm sorry, I don't want it to be 3 to 4. We need at least 4 in there. If you're in 5, again, you're only taking Sunday off. You're going to have a spare day to make the schedule work. Make a note of everyone in your group. I will try and record these in case anything goes terribly wrong. The idea is we're going to go in for about, I know everyone's done this once before, so I'm hoping we can get out in about 4 minutes, getting this first round done. Does that sound reasonable to everyone? Everybody think they can do a schedule with 4 people in about 4 minutes?
Like one schedule, just one schedule?
That's all you're doing. You're just doing week 1. You're
Okay.
going to go in, you can talk to each other, and you're going to figure out week 1. Okay? Then we're going to come back, we're going to talk about what worked, what didn't work, and then everyone's going to go into the widget to try and do week 2 without talking to each other. Then we'll come back, and then we'll try and do week 3, because hopefully we will have learned something on week 2 and gotten notes. And then once we finish week 3, we'll hopefully get on to lesson 4. Okay? Does that sound reasonable to everyone?
Yeah.
Okay. Thank you for being the voice of the class. Here are the breakout rooms. We're going in at 10:29. We'll come out about, 10:35.
Mr. Smith, you're muted. Swift.
Thank you. It's just so random. Welcome back. Let's either let's try and put them in the chat. Can you put down any things that really worked well or things that didn't work well in setting up your schedules? If people can add things in, I'll read them out. So what worked well? Let's start with that. It's this idea that you're trying to make a systematic.
For our group, it really worked when one person just like said, I have this person this day, and just like named all the people that they had, and then the next person did the exact same thing until everyone was full.
So each person was completing, one at a time, each person was completing their schedule and then moving on to the next one to validate whether that would work. Is that right?
Yes.
So what would happen towards the end when people's schedules were already booked and you were trying to figure it out?
I mean,
or did you pass along the schedule? Well, I guess you guys could talk to each other.
yeah, so everyone was listening. And
okay, so what's going to happen with that once you can't talk to each other?
Then we can just, well, actually we did talk about that. We said,
go ahead.
I don't know if this is allowed, but we just said next week everyone's just going to shift down a day.
Okay, if you can, that's a little fudgy, but see how that works. Ideally, you don't want to have a template like that you've already arranged, because then you're not going to get the benefit of trying to figure out how this works. What you want to be doing is trying to exchange messages on this broadcasting system that's in there, and it's going to get. You'll see. So I think you can sort of do the same thing that you did before in the widget, that if one person says, okay, I'm planning on meeting with Jim on Monday, Carol on Tuesday, and Bob on Thursday, you send that out to the group. The next person can then say, okay, I will meet with whoever, and then the next person, that should work out that way. Let me read out some of these. It was easy to communicate as to who is meeting with who. It worked well and we all communicated and talked things out. It was pretty easy with only a few people and a lot of days. We had to move a few days around because of conflicts, but we were able to coordinate our open days and figured it out quite well. Okay, what were problems that you ran into? So those are all the easy parts, was talking to each other. What were any particular issues? The one issue was when they got to the end, people's schedules were conflicting, that one person was booked and that somebody else needed to rearrange their schedule to accommodate that, to make sure that everyone's schedule matched. Anybody else have any particular problems? Come on, something must have been problematic in there. There certainly were problems yesterday. Okay, if everybody feels solid on this, I am fine. Let's get into the widget, okay? Let me, just for fun, I'm gonna show you, oh, actually, I don't think I have it up. Hang on. No, I didn't do it. I can show you the next one, but not, I was just gonna show you what it looks like. Okay, so in you go. Let's go. I'm going to open all the rooms again. You'll go back in your room, and this time you guys are going to figure it out going through the internet widget in lesson 3. Okay? Everybody solid on that? Know what you've got to do? Ideally, try and create a new schedule. Don't try and just shift one, or at least try and talk to each other about doing that in this widget, not outside when you can talk. Just because I want you to get the benefit of trying to figure things out. This is going to help you understand how different it is once you get a router. All right.
And
So
so we're supposed to only do week 2 now.
you're just going to do week 2. What we learned from trying to do this, we're going to come back. We're going to do the same cycle. Let me give you 7 minutes because this is going to be longer. So we're going to come back at about 10:48, 49. We'll talk about what worked, what didn't work, and then we're going to try and get week 3 done, hopefully quicker now that everyone's done it once and understands it better. Okay? So I'm going to bring people out around 10:49:50. Any questions? Just be careful going, make sure you know who you're hooking up with, and just be careful not to close your tab once you go into one of those rooms in code.org.
Mr. Swift, you're muted.
Thing. I got my screen working. Oh, team, what will we do without each other? Thank you. So this was what we were doing. We've completed week 2. You join a room on the simulator. See how this is what we were doing in U2L2 was the idea of how many different lines can connect everyone when you're broadcasting. Okay, so right now you want to be filling in on your worksheet. What problems did you encounter? How do you plan on fixing them in week 3? Can anyone share out some of their problems or put that in the chat maybe?
We couldn't see each other's names. So as a solution, we just typed like our name, whoever was talking, and then a dash, and then started our message.
Perfect. No, that's a real problem. Hang on. Sorry, I've got to stop sharing so I can get my chat. Look, there's everybody. So that's a brilliant suggestion. Who else was having difficulties with this? So that's one that all of a sudden you can't just talk to your friends. You've got to address it to particular people. William Swift is going to be meeting with John on Monday, Bob on Tuesday. Otherwise, you don't know who's talking. Who else has an insight into this? So that was a problem they overcame, and they came up with a solution. What other problems do you have?
It was hard to address a message to a specific person. So you kind of had to, like, you had to say who you were talking to in every message.
Right. And this is going to be very fundamental to the next lesson, where all of a sudden you are sending messages to a particular person. So what we're learning about here is what a network is, a broadcasting network is like. You are reaching out to everyone versus a narrowcasting where you're messaging an individual. All right, I think anybody else have cogent insights? Something that might help anyone as we try and do this quicker in this next round. What do you guys think we need in terms of time to get week 3 done? 5 minutes?
Yeah, and week 3 is without talking, right?
Week 3, all you're doing is the exact same thing you just did. You just need to shift, your dates. Try not to just rotate one notch on everyone, but talk to each other. But that's the idea. You're just doing the exact same thing, but ideally you're a little smarter and wiser about how to go about it. Does that make sense?
Yeah.
Okay. So I'm going to give everyone 5 minutes and we'll get out, and then hopefully we can get into lecture 4 or lesson 4. Okay, 5 minutes. We'll be out probably around 11 o'clock. If you guys get done, come back in the room.
You're muted again.
Mr. Swift, you're muted.
It clicked on the moment the rooms all opened. That was weird. Perfect, thank you. Okay, so what we need to be doing now is you guys need each individually, you need to write down the rules that you were using to establish that schedule. So it's take down, your collective rules. You guys can all, well, I guess you're all separated now, but you could talk to each, well, I don't want to put you back in rooms. We want to move on. Just write down the rules or what seemed to work for you in the room. You could write some sample messages that follow your rules. Like, what were you doing? Like, I know in talking with people, they were saying, you're broadcasting, so you needed to identify, first you need to identify yourself. Then you list your schedule. You send that out and the next person answers that schedule with their schedule. That's the kind of rules that we're looking for. Let me go, you can be writing that down while I start introducing us into fabulous unit. Oh, that's what we got. We got a video. Okay, so do that while we watch the video. Are you seeing this full screen?
No.
No.
No. I can do
Hi,
this.
my name is Paula, and I am a software engineer at Microsoft. Let's talk about how the internet works. My job relies on networks being able to talk with one another. But back in the 1970s, there was no standard method for this. It took the work of Vint Cerf and Bob Kahn to invent the Internet Working Protocol to make communication possible. This invention laid the groundwork for what we now call the Internet.
The internet is a network of networks. It links billions of devices together all around the globe. So maybe you're connected with a laptop or a phone through Wi-Fi, but then that Wi-Fi connection connects to an internet service provider or ISP, and that ISP connects you to billions and billions of devices around the world through hundreds of thousands of networks that are all interconnected. One thing that most people do not appreciate is that the internet is really a design philosophy and an architecture expressed in a set of protocols. A protocol is a well-known set of rules and standards that, if all parties agree to use it, will allow them to communicate without trouble. How the internet actually physically works is less important than the fact that this design philosophy has allowed the internet to adapt and absorb new communication technologies. This is because in order for a new technology to use the internet in some fashion, it just needs to know which protocols to work with. All the different devices on the internet have unique addresses. An address on the internet is just a number, similar to a phone number or a sort of street address that's unique to each computer or device at the edge of the network. This is similar to how most homes and businesses have a mailing address. You don't need to know a person to send them a letter in the mail, but you do need to know their address and how to write the address properly so the letter can be carried by the mail system to its destination. The addressing system for computers on the internet is similar, and it forms part of one of the most important protocols used in internet communication, simply called the Internet Protocol, or IP. A computer's address then is called its IP address. Visiting a website is really just your computer asking another computer for information. Your computer sends a message to the other computer's IP address, and it also sends along its origin address so the other computer knows where to send its response.
You may have seen an IP address. It's just a bunch of numbers. These numbers are organized in a hierarchy. Just like a home address has a country, a city, a street, and a house number, an IP address has many parts. Just like all digital data, each of these numbers is represented in bits. Traditional IP addresses are 32 bits long, with 8 bits for each part of the address. The earlier numbers usually identify the country and regional network of the device. Then come the subnetworks, and then finally the address of the specific.
What? Sorry.
I want to go to
about internet addresses, a system called the domain name system.
Much more popular than even Venn surf imagine. Finally, the address of the specific device. This version of IP addressing is called IPv4. It was designed in 1973 and widely adopted in the early 80s and provides for more than 4 billion unique addresses for devices connecting to the internet. But the internet has turned out to be much more popular than even Venn surf imagined, and 4 billion unique addresses won't be enough. We're now in the middle of a multi-year transition to a longer IP address format called IPv6, which uses 128 bits per address and provides over 340 undecillion unique addresses. That's more than enough for every grain of sand on Earth to have its own IP address.
Most users never see or care about internet addresses. A system called the domain name system, or DNS, associates names like www.example.com with the corresponding addresses. Your computer uses the DNS to look up domain names and get the associated IP address, which is used to connect your computer to the destination on the internet.
Then it goes a little something like this.
Hey, hi there. I want to go to www.code.org.
I don't know the IP address for that domain. Let me ask around. Hey, they know how to get to code.org?
Yeah, I got it right here. It's 174.129.14.120.
Oh, okay, great, thanks. Yeah, I'm gonna write that down and save it for later in case I need it. Hey, here's that address you want.
Awesome, thank you.
So how do we design a system for billions of devices to find any one of billions of different websites? There is no way one DNS server can handle all the requests from all devices. The answer is that DNS servers are connected in a distributed hierarchy and are divided into zones, splitting up responsibility for the major domains, such as .org, .com, .net, etc. DNS was originally created to be an open and public communication protocol for government and educational institutions. Because of its openness, DNS is susceptible to cyber attacks. An example attack is DNS spoofing. That's when a hacker taps into a DNS server and changes it to match a domain name with the wrong IP address. This lets the attacker send people to an imposter website. If this happens to you, you are vulnerable for more problems because you are using that fake website as if it is real. The internet is huge and getting bigger every day, but the domain name system and internet protocol are designed to scale, no matter how much the internet grows.
Okay. What are the similarities and differences between the internet protocol and the addressing rules are class-made? Would rules like ours or the IP work if they were secret? What do you think, team? No, we're not fitting anything in the schedule for week 4. We're skipping week 4. But think of the rules that you just wrote down. Would rules like ours or IP addresses work if they were secret? This is a pretty straightforward question. Somebody, Lily Kreindler, save me.
No.
Right. It wouldn't work if they were secret because nobody could send you anything. It needs to be public so that messages can get where they need to go. Okay, protocol. These are vocabulary words that you probably will be responsible for with the AP. Protocol is an agreement, agreed upon set of rules that specify the behavior of some system. IP address, the unique number assigned to each device on the internet. Internet protocol, IP, a protocol for sending data across the internet that assigns unique numbers, IP addresses, to each connected device. Okay, we've made it to 4. Previously, we saw that the internet uses the internet protocol and IP addresses to communicate across the shared internet. How is this system similar to how we send letters in the mail? How is it different?
It's similar because you're sending a message through an address, which is what an IP address is. You're just sending it digitally. You're sending yeah.
No, that's perfect. And the idea is that instead of a street name and a number, you've got things like, your city, your region, your locale, and those are what are creating the specificity needed to deliver the message to you. Okay, for the rest of class, we're going to experiment with this version of the internet simulator. You may join a router and also you type your IP address in the chat so classmates on other routers can send messages to you. Okay, we're going into lesson 4, the updated internet simulator. There is an activity guide. I don't think we need to worry about that right now. Open the internet simulator, connect to the same router number as your group. Step 2, say hello. Use the updated version of the internet simulator to send a message saying hello to everyone in your group. Everyone now has an IP address. This will be important in today's simulation. Okay, open the router logs. Look at the messages. You can see what people are sending. Okay, so all we're trying to do is get into lesson 4. Hang on, I'm going to stop sharing. I'm going to start sharing on my fabulous desktop. So you are going to go into code.org, lesson 4. Hang on, let me. So if I go in here, I go into code.org, unit 2, internet simulator routers. This is where we want to be going. It's going to be very similar. You're going to need to pick your section and then join your section. Same rules apply. We're going to probably have weird issues when we come back next time and need to make extra rooms. But that's it. What your network is going to end up looking like. Oh, well, don't worry about it. You'll see when you get in there. I had this set up, but it seems to have let me out, so I'm not going to worry about it. Okay, so we've only got 3 minutes left. Let's not go into the rooms and you guys can just try and connect with each other. Does that make sense? You know who your partners are. So just go into the room and try and work with your partners for the next 3 minutes. All you're doing is trying to get a little familiarity. The idea is you've got to type an individual's IP address into the to box in order for them to receive your message. So you're going to be, also the idea, once you get in there, you can start posting your personal IP address in the chat and other people can text you or email you. Anyone have questions? Anyone having problems?
So we're going to lesson 4 now?
You're going into 4.
Okay.
So if I go into unit 2, lesson 4, you want to be looking at the internet simulator routers. When I click on that, it's going to send me to the same type thing. I've got to pick my period P2 and join the section and then find my teammates and get into a room.
And then we're doing week 4.
No, you're not doing week 4. You are no longer in lesson 3. You are in lesson 4. There is a worksheet for lesson 4, but we've got 2 minutes, so you're not going to get to that today. All that's due today is your L3 worksheet. Okay? We're just trying to get a little familiarity with how to get into and deal with this widget because we're going to do this first thing on Monday. Okay, and class is over.
Thank you.
Okay, so great job, team. We've made it into the lesson 4 widget. We'll pick this up. It's all starting to make sense.
Thank you.
Thank you.
Thank you.
You bet. Have a great day.
Thanks.
My pleasure.